Hi everyone! Our Earth is covered by two layers of ozone molecules. However, you must be surprised to know that both layers have a contrasting impact on us. The upper layer protects us from the UV rays of the sun, while the lower layer causes air pollution. Let's unravel the story about the protective layer of ozone. For nearly 1 billion years, ozone molecules have protected life on Earth from the harmful effects of the ultraviolet rays of the sun. These molecules are present in the stratosphere and have a maximum concentration at a height of about 15 and 40 kilometers above the Earth's surface. Hence, this layer is called the ozone layer. Let us study the interaction of UV rays with the ozone layer. The sun emits three kinds of UV radiations: UVA, UVB, and UVC, respectively. The UVA radiations pass undisturbed through the atmosphere and reach the surface of the Earth. However, most of the UVB and entire UVC radiations are absorbed by the ozone layer and hence cannot reach the Earth's surface. What happens to these absorbed radiations? Well, the ozone molecules absorb UVB radiations and decompose into oxygen, along with the liberation of an oxygen-free radical. This oxygen-free radical then further reacts with another ozone molecule to form oxygen. These oxygen molecules absorb the UVC radiation and break down into oxygen-free radicals. The oxygen-free radicals thus formed further react with other oxygen molecules, resulting in the formation of ozone molecules. Thus, by absorbing the UVC and UVB radiations, a dynamic equilibrium is maintained between the production and decomposition of ozone molecules, and the thickness of the ozone layer is maintained. Also, due to this process, the Earth's surface is shielded from these harmful UVB and UVC radiations. The amount of ozone in the atmosphere is measured in Dobson units, DU. Prior to 1979, scientists had not observed concentrations below 220 DU. But in the early 1980s, scientists began to realize that the natural sunscreen of the Earth was thinning dramatically over the South Pole each spring. This large spot on the ozone layer came to be known as the ozone hole. Let us now study what causes the depletion of the ozone layer. Aerosol sprays, refrigerators, and air conditioners let out a very non-reactive group of gaseous chemicals known as chlorofluorocarbons into the atmosphere. As these reach the upper level of the stratosphere, the powerful UV radiations break the CFCs to release chlorine-free radicals. These chlorine-free radicals then react with ozone molecules to form chlorine monoxide free radicals and molecular oxygen. The reaction of chlorine monoxide with ozone produces more chlorine-free radicals. Thus, the chlorine-free radicals are continuously regenerated and cause the breakdown of ozone. Thus, CFCs are the transporting agents for continuously generating chlorine-free radicals into the stratosphere and damaging the ozone layer. So now you understand what the problem is. In steps 2 and 3, the destruction of the ozone layer occurs without absorbing any harmful UVB, unlike the previous mechanism. Hence, UVB radiation is able to reach the earth and gives sunbathers skin cancer. To summarize, the ozone layer is mainly present in the lower region of the stratosphere, which is about 30 kilometers from the Earth's surface. The ozone layer acts as a shield against the harmful UV radiations from the sun, which can cause diseases such as skin cancer. The depletion of the ozone layer is caused by gaseous chemicals called chlorofluorocarbons and can be reduced by a substantial reduction in the use of ozone-depleting gases. You know that fossil fuels are widely used in industries, power plants, and automobiles. However, they emit a lot of harmful gases, and these gases form a colloidal mixture with dust particles. Do you know this mixture is one of the main causes of air pollution? Then is there a preventive measure? Let's find out in our upcoming videos.